Hey guys, it's Mary and welcome back to Study Journey. I'm back with another AMC Problem of the Week video, and this is going to be about using squares to solve a problem about percentage growth. So we're going to be using growth percents to find the answer of the problem. And without further ado, let's get on with the video. This is AMC 10A Problem 19 of the year 2011. In 1991, the population of a town was a perfect square. 10 years later, after an increase of 150 people, the population was 9 more than a perfect square. Now, in 2011, with an increase of another 150 people, the population is once again a perfect square. Which of the following is closest to the percent growth of the town's population during this 20-year period? Your answers are 42, 47, 52, 57, and 62. Now, let's look at some keywords. So, first, it began in 1991 and the population was a perfect square. 10 years later, so that would be in 2001, there was an increase of 100 people and it was 9 more than a perfect square. And now, 2011, with another increase of 100 people after this 150 increase, so that would be a 300 people increase from the year 1991, the population is once again a perfect square. And it is asking you for the closest to the percent growth of the town's population during this 20-year period. So let's list some variables here. So we know that the population in 1991 is a perfect square. So let's say this would be p squared. And then 10 years later, which is 2001, the population is 9 more than a perfect square. So let's say this is q squared. This is a perfect square, and then plus 9. And now in 2011, it is another perfect square. So let's say this is r squared. Now let's solve the problem. So we know that the population in 2011 is q squared plus 9. Well, we also know that this was after 150 increase from the population of 1991. So this would equal the population of 1991 plus 150. So when we solve this, we can see that we can put the variables together. Q squared minus p squared equals 141. So this must equal, it would be q plus p times q minus p. This equals 141. Now we can just try to find out the factors of 141. Because p and q are both positive integers, with q is greater than p, because this is a growth of 150 later and this is only plus 9, so therefore q must be greater than p, then we can know that q and p and q plus p are both factors of 141. So if we factorize 141, it can either be 1 times 141 or 3 times 47, and these are the only two types of ways we can factor it. So let's just do it by case. So first case, if it was 1 and 141. Well, we know that q minus p is less than q plus p. So if q minus p is 1 and q plus p equals 141, we can solve by adding these two equations together. So 2q plus 0 equals 142, and q would equal 71. And then we're going to get p is equal to 70 when we plug it back in. So we know that right here, 2011 is after, so from here to here, they added 150, and from here to here, it was also another increase of 150. So this would actually just equal p squared, which is the initial population in 1991, and then you add 300. And remember, this is also a perfect square, which is the r squared. So p is 70, so 70 squared plus 300, is this a perfect square? Well, we know that this is 4,900, and then you plus 300. And this is not a perfect square. So we can see that this scenario doesn't work. The first scenario, which is 1 times 141, this would not work. So moving on to our next case, where it would be 3 times 47. Again, q minus p would equal 3, and q plus p is equal to 47. 2q is equal to 50, and q is equal to 25, while p is equal to 22. From here, we do the same thing, and we see that 22 squared like p squared, and then you add the 300. This is equal to 784. And we know that this is equal to 28 squared. So this is a square, and so this is the correct pair. Now, since we know that this is the correct pair, we know the values of q and p. So we know we can solve all of these three variables. P is 22. So the population in 1991, this would be 22 squared, which is 484. And then in 2001, it would be 480 plus 150, which would be 530. In 2011, it would be at 300, so that would be 784, which is equal to 28 squared, like we said here. 22 squared, and this is 28 squared. Since we are trying to find the percent growth of the town's population during this 20-year period, we're trying to find the percent growth from here to here. And we know this is a 300 change. So the number increase will be 300. And to find the percent, we would put it over the initial. We will put this over the initial population, which was a 484. And if we times by 100%, this would get us a percent growth. And this is about 62%. So that would be our answer, which is the percent growth. Now, looking at our answers, we can see that the answer will be E, 62%.